So good morning, students. So yesterday we started discussing about the traveling salesman problem. So this is one kind of branch and bound algorithms. Okay. So in continuation with yesterday class, today also we are going to discuss about traveling salesman problem. So followed by we will discuss about an abstract problem. Is it clear? So traveling salesman problem, by means of two ways you can able to solve the problem. So with respect to the continuation of the yesterday's class, hope my screen is visible to you. So right now only 48 students have joined. What about others? See here, so this is the problem yesterday we started discussing. So this is the given graph. This is undirected graph, isn't it? So to solve the traveling salesman problem, the input may be either undirected graph or the directed graph. For both the graphs, you can able to solve the problem. So this is the given weight matrix. Okay, so for example, if you move to 1 to 2, then the weight matrix assigned is 20. But if you move from 2 to 1, the weight will be different, 15. Okay, so this is not identity matrix. Okay, so this is the given weight matrix. So this is the method one we have started discussing yesterday's class. So this is nothing but given a weight matrix. So from the weight matrix, take the minimum element from each and every rows. For example, if you refer the first row, the minimum element is 10. If you refer the fourth row, the minimum element is equal to 3. Okay. And now we are going to subtract each and every element in the first row from 10. Similarly, if you take fourth row, each and every element will be getting subtracted by 3. Okay. So this is row wise reduction. So after performing row wise reduction, so this will be the output matrix. So here INF refers infinity. Okay, so here we go to mathematically use infinity, but since I am using Word document, it is difficult to insert infinity. So I simply put INF. So this is a row wise reduction result. Okay, now you go to check whether all the rows contain 0, at least 1 0. Yes. So here all the rows contains at least 1 zeros. And now you go to take the minimum element from each and every column. So if you look the first column, the minimum element is equal to 1. If you look the second column, the minimum element is equal to 0. If you look the third column, the minimum element is equal to 3, like that. Okay. So this will be the minimum element. Again, you are going to subtract each and every column with respect to the concerned minimum value assigned here. For example, if you take the first column, each and every cell will be getting subtracted by 1. If you go to the third column, each and every element will be subtracting by 3. Okay, it should be subtracted by 3. So this is column wise reduction result. So for the column wise reduction, you go to take the row wise result as the input and you go to proceed. Okay, subtract each element from the concerned minimum element of that column. So this will be the final matrix. Okay, so to process further, this matrix will be considered. Is it clear? Now we are going to find out the reduced cost. So reduced cost in the sense that from the original matrix, okay, you go reduce some minimal reductions. So that reduced value you go to calculate. How will you calculate reduced cost is simply add all the row wise values. This is sum is equal to 21. Similarly, here you go to add all the column values. This is nothing but sum is equal to 4. So this is sum is equal to 4, isn't it? So 21 plus 4, that is nothing but 25. So this is the reduced cost. This is what the reduced cost for the current matrix. Okay. So now, since it is a traveling salesman problem, if the starting vertex is not given to you, let us assume that the first vertex is the starting vertex. If in the problem itself they have mentioned the starting address, starting vertex, from that vertex you have to start the problem. Is it clear? So here this is the resultant matrix. So this is the resultant matrix with reduced cost of 25. Okay. So in the reduced matrix, you have to check whether all the rows and columns have 0 or not. Okay. You please check it out. If you check it out, all the rows and columns have zeros. Then you can able to proceed. So now I am going to traverse from node 1. So what are the possibilities? So I am having 5 nodes. So I can able to travel from node 1 to 3 or 2 or 4 or 5. So before that, let us take upper bound is equal to infinity, since we can't able to know the upper bound value. Okay. So now we are going to find out the cost of C of 1, 2. C of 1, 2 is nothing but it is a traveling cost from node 1 to node 2. Okay. So how will you find out C of 1, 2? So for this, always you have to take this matrix. In the first level, we are solving the first level. To solve the first level of matrix, okay, to solve to find the cost of the first level, always you have to take this matrix. You have to take this matrix. So this is the resultant matrix for the first level. Actually, I have prepared this Word document. So this is the resultant matrix for the first level. Okay. So now C of 1, 2. So in the C of 1, 2, just to make first row and the second column as infinity. Okay. So take this matrix and in that matrix make first row and second column as infinity. Okay, then the result will be this one, first row, second column. As well as you have to make reverse, C of 2, 1 also infinity. Since we can't able to travel back, isn't it? Now we fixed that starting the node is 1, so 2 to 1 is not feasible. Since you have so many in between vertices, so just to make C of 2, 1 is also infinity. Is it clear? And again you have to check whether all the rows have 0. The first row is infinity, leave it. Second row contains 0. Third row also contains 0. Fourth one contains 0. Fifth row also contains 0. Similarly, for each and every column you have to check it out. So here all the rows and all the columns is having 0. So this matrix can't be reduced further. So here the new reduced cost is equal to 0. So here the new reduced cost is equal to 0. Okay. Now find out the new cost of C of 1, 2 is nothing but C of 1, 2, that is old cost. New cost. So C of 1, 2 is nothing but from the resultant matrix you have to take C of 1, 2. To travel from node 1 to node 2, what is the cost? 10, isn't it? So 10 you have to take it out. So 10 plus this matrix reduced cost. C of 1, 2 is 10. Okay. Then for this matrix the reduced cost is equal to 25. You have to take it. And the new reduced cost, here the value is equal to 0, you got to add 0. So this is 35. Okay. So this will be entered here. See here. So this is 35. Now let us see how will you find out the C of 1, 3. So for C of 1, 3, just you have to make first row and second column as infinity. See here. First row, second column as infinity, as well as make C of 3, 1 as also infinity. Okay, and you go to check whether all the rows and columns have 0. But here, if you look the first column, which does not contain 0. Okay, if it does not contain 0 means take the minimum element. So just to pick the minimum element, the minimum element is equal to 11, isn't it? So minimum element is equal to 11. So in the first column, we go to find out the new cell values such a way that the cell value is getting subtracted by 11. So the first column, new first column value will be infinity. This one will be 1 and this will be infinity. This one will be 15 minus 11 is 4 and this will be 0. Okay. So now the new reduced cost is equal to 11. since the first column is getting subtracted by 11. So in this case, new reduced cost is equal to 11. Okay. Similarly, you have to find out cost of C of 1 comma 3. So C of 1 comma 3 is nothing but C of 1 comma 3. You have to take it from the resultant matrix of first level. That is nothing but 17. Reduced cost is 25. Plus here new reduced cost is equal to 11. So in the previous case, this is the final matrix. So our new reduced cost is equal to 0. Is it clear? So in the previous matrix, our new reduced cost is, we didn't find any calculations. So our new reduced cost is equal to 0. But here, since the first column does not contains 0, we have to consider the minimum element, and each and every element of the first column is getting subtracted by 11. So my new reduced cost is equal to 11. Sorry, here it is 53, I think. So this cost of 1 comma 3 is equal to 53. Only 43 now. Okay. So the new reduced, so the cost of C of 1 comma 3 is equal to 53. So similarly, go to find out C of 1 comma 4 and C of 1 comma 5. Okay. So this will be the final matrix. This is the final matrix traversing from node 1 to 2. So this is for node number 3, and this is for node number 4, and this is for node number 5. Okay, so this is the final matrix, and this is the first level equivalent branch and bound tree. Okay, and from this level, how will you proceed further? So you have to select the node such a way that which contains minimal weight. Okay, if you compare these 4 nodes, the node number 4 contains least weight, so this may act as a root node now. Okay, so the resultant matrix is taken from node number 4. Now we go to proceed from node number 4. We go to take this matrix. Is it clear? So C25, this contains a minimal cost, so you go to proceed from node number 4. So you go to take this matrix. Is it clear? So from node number 4, what are the other possibilities? From node number 4, you can traverse to node number 2, or node number 3, or node number 5, isn't it? Is it clear? From node number 4, you are going to traverse from node number 2. See here. So this is mentioned in outside node number. So from node number 4, you can travel to node number 3, node number 3, or node number 5. See, so already node number 2 is taken here. So they have taken node number 6 or 7 and 8. Even if you want, you can put a 2, 2, 2, 3, 4, 2, 3, 5 also, no issues. Okay, but for clear representations, so node number will be represented by 6, 7, 8, but see the actual node number. So this is the node number with respect to the tree. But see the actual node number that is denoted outside this node. This is 2 and this is 3 and this is 5. Okay, so now this is the input. Now by considering node number 4, this is the input. Now the reduced cost is equal to 25. You have to take 25. Okay, so now the reduced cost is equal to 25. So from node number 4 to 2. So don't see the number inside the circle. See the number which is presented outside the circle. That indicates actual node number. Dear students, see the number which is represented outside the circle. That is actual node number. So here we have node number 4 and node number 2. So just to find out the cost of 4 comma 2, to find out the cost of 4 comma 2, just to make 4th row and second column as infinity. Okay, so 4th row, second column as infinity. Also you have to make, so also you have to make C of 2 comma 1 is also infinity. See here. So again you can't able to travel back to 1. So from node number 2, you can't able to travel back to 1 since we have some more intermediate nodes. So also make it C of 2 comma 1 is also infinity. Is it clear? C of 2 comma 4 is again set to infinity. So in addition to that, you have to make C of 2 comma also, since we can't able to go back to from node 2 to node 1 also. Since we can't go back from node 2 to node 1. Okay. So from this matrix will be formed to find out the cost of C4, 2. Now check all the rows or not. Okay, if it is so, find out the new cost. Just wait a minute. But just wait a minute. Okay, so this is the cost of C4, 2. This is nothing but from the input matrix you have to take C4, 2. What is C4, 2? This is 3, isn't it? So 3 plus the cost of fourth node, that is 25, plus we didn't perform any reduction, so new reduced cost is equal to 0. So 3 plus 25, that is equal to 28. Okay, so in this manner you have to find out the cost of node number 4 to 3, also from node number 4 to 5, and again compare which one is least. Node number 2 is contains least, so we have to travel from node 1 to node 4, then 4 to 2, then again we have two other possibilities. One is from node number 2 we can travel to node number 3 or node number 5, isn't it? So this is for 6th and 7th node. This is the resultant matrix. Okay, and this is the resultant matrix for 9 and 10. 9 and 10 is nothing but this is 9 and 10. Okay, that is from node number 2. From node number 2 you can either travel to node number 3 or node number 5. You have to repeat the same process. So again, if you compare the cost, this will be least 1. Okay, so node number 5 is having least 1. So see the path. Your starting node is 1, then 4, then 2, then travel to 5. So remaining left out node is 3. So the last leaf node is 3. See, this is the last leaf node. Actually, for the calculations, here the node number given as 11, but actually this is a node number 3. Okay, so for the node number 3, there is no need of any cost. Okay, straight away you can move from node number 5 to node number 3. So the total cost is equal to 28. So up to this only there is need to calculate 28. There is need to find out the path, correct path. Okay, you have to select out the path such a way that it contains minimal weight. So here the cost is equal to 28. Okay, and whatever the path, so you have to travel from node number 1, then 4, then 2, then again 5. It's not 5, only one time 5. Then node number 3, again you have to travel back to node number 1. See, this is a circular path. So traveling salesman problem is nothing but it's just like a Hamiltonian cycle problem. So where each and every node or vertex is visited at least once